Let's start solving today's LeetCode daily challenge question. So the question is find the largest almost missing integer. So let's understand it. We are given a nums array and an integer k. An integer x is almost missing from nums if x appears in exactly one subarray of size k within nums. Okay, so there will be an integer x is defined as almost missing if that is only present in a exactly one subarray of size k, and we have to return the largest almost missing integer from nums. If no such integer exists, return -1, and the subarray definition is given. So let's analyze it. Even though it is a easy level question, you should understand the question properly, otherwise you might get confused. So we have k and we have nums. In that nums k size subarray, we have to find, and there will be what is a missing integer. Missing integer defined as what? It exactly appears in one subarray. See, this doesn't mean that we can't have a subarray like 1 to 1. Okay, because this is in the same, I'm talking about, let's say, instead of taking this example, let's say I have, okay, um I'll explain with the edge case. That is a edge case, but it exactly appears in one subarray. Okay, if you have an example of nums is equal to, let's say, 0 and 0, but your k is equal to 2, in that case my subarray, how many possible subarrays are? This only one subarray, but it exactly appears in one subarray. It's not written that it exactly once in the subarray. Okay, there is a difference of one subarray and once in a subarray. Here answer is not -1, the answer will be 0. Why? The missing integer is it appears exactly in one subarray, not once in a subarray. So there is only one subarray possible here for this case, and in that 0 is only appearing, so it doesn't matter how many times it is appearing. Also, if let's say this is the case of k is equal to 2, but the size is 2, so we can generalize it and say if my k is equal to n, if my k is equal to n and n is the length, nums dot length, in that case how many subarrays I'll get? Only one subarray I'll get, that is of n size, of k size, right? So in that case also it doesn't matter how many times that number appears, we just have to return the maximum, max element of an array. Okay, now if my k is equal to 1, let's understand these cases first and then we'll go to the core idea. Let's take k is equal to 1. If my k is equal to 1, that means each element in the our array will be the subarray. Okay, subarray size of 1. So in that case, we just can't take the maximum of all. What we have to do is we have to maintain a map of frequencies for each element. If the frequency is more than one, that means that element is there in multiple subarrays, so we cannot consider that and we cannot take the maximum of that. So if the frequency is 1, okay, after counting everything, then only we will consider the max for this. Okay, max of this, not frequency, the element. We understood the k is equal to 1 case, k is equal to n case. Now let's take the actual example. Okay, 39217. We have the example of what? 3, 9, 2 and 1, 7. What is the k? K is equal to 3, right? Yes. Now, how many subarrays are possible is 3, 9, 2 of size 3, 9 to 1 2, 1, 7. Yes, correct. So my 2 is appearing. Okay, let's go one by one, not directly 2. So my 3 is appearing in how many? In only one subarray. My 9 is appearing in how many subarrays? 2 subarray. My 2 is appearing in 3 subarray. 1 is appearing in 2 subarray. 7 is appearing in 1 subarray. So we have to return what? Largest. That's why we are taking the maximum in case of this, right? The largest is 7 here. Why this is appearing only one subarray? Okay, in one subarray, not the occurrence. Okay, if I have the 7 in the same but this is not the case for these cases, but it will be for k is equal to 1. That's why I was not able to explain before for such cases. This is the only case, but we have to check if that element is in single subarray. Now if my k is greater than 1, okay, if my k is greater than 1, then can I say that any element in that array between the index 1 to n minus 2 will be repeated in multiple subarrays. This 9 will be in 3 also, 9 will be in 2 also if k is greater than 1. Let's say minimum size is 2. If we expand, then it will include in all the subarrays, okay, which is there of that size. That means 3. If I size have 3, that 9 appeared 2 times. If I size have 4, also it appeared 2 times. 3, 9, 1, 9, 2, 1, 7. Okay. So similarly, I can say, what I can say, that these are out of scope of our answer. So remaining is only the first element and the last element. And it doesn't mean that we just return the maximum of these two elements. What we have to do is, if there is a possibility, right, that 393 is there. So in that case, I should exclude this 3. So what I should do, I should consider the possible answers as my start element and my end element, and I should traverse from this first index to last minus 1, that is till n minus 2, 1 to n minus 2, and I should check if my start is equal to, if there is any element which is equal to my start, or if there is any element which is equal to my end. If it is equal to start, then we should not consider this in our answer. So I'll do it as minus 1. I'll change it as minus 1 and also minus 1, and at the end we just have to return the maximum. You just got that core idea why we are discarding from 1 to n minus 2 is, if my k is, for k is equal to 1, we already handled the case k is equal to 1 and k is equal to n. Now the question arises when k is greater than 1. Okay, and the case where k is not equal to n. If k is greater than 1, the minimum subarray size is 2. So my elements from I is equal to 1, the index 1 to n minus 2, it will appear in multiple arrays, definitely. So we can't take that answer. So we have only two possibilities, as first element and the last element. But we just can't return the maximum of 2, because the first element can also appear in the middle or anywhere in the array. So if it is appearing, that means it is also including in some other subarray. So what we have to do is, we have to check that first element is unique, not repeated in the rest of array, and last element also the same thing we have to check. If it is repeating, we will not consider it. If it is repeating, both the ways. And if consider my first element and last element are same, so definitely I can say that there is no such missing number exists, because what we are finding the number should exactly appears in one subarray, not that it should repeat in same subarray or anything. That first number will have, even if my k is equal to 2, let's say this is 3, this is 2, my both number are same, I have 3 9, and also I have this what 1 3. So 3 is appearing 2 subarrays. Okay, so anyway my answer will be minus 1 as per question. Now let's start coding. We understood the question, let's start. So let's take int n is equal to nums dot length. If my k is equal to n. If k is equal to n, that means I just have to find the maximum. We don't care if it is repeating because there will be only single subarray, and that is fine. So int max, let's take -1, and for int I is equal to 0, I less than ni plus plus, we have to maximize this. Max is equal to mat dot max of max comma nums of I. Okay, now this is done. Once we get the maximum, we'll just return the max. Okay, if k is equal to n. Now if my k is equal to 1, in that case we have to store the frequency also. So I will use the map, that is integer comma integer, mp is equal to, or you can take any name, or I'll take the hash map. Now what we will do, we will include all one by one less than n I plus plus, and here what we will do is mp dot put what nums of I comma, we have to increment it, right? So I'll get first, so mp dot get or default. So if there is this number exists, it will return the actual count, else it will return the number I'm passing, that is 0 and plus 1, because we are incrementing, right? Now next is again here also we have to find max. I'll take the initial -1 for int I is equal to 0, I less than, and I, you can traverse this map also, but I'm traversing the array instead, and I'm checking if my, if or let's take int c is equal to mp dot get nums of I. If c is equal to 1, then only we will consider it in our answer. Okay, because each is a one single subarray. Then I'll do max is equal to mat dot max of max comma nums of I, and then we will return here also max. Now two cases done. Now our core idea, let's take in start is equal to, start will be what, my nums of 0 element, and int end will be what, nums of n minus 1 element. And if my start is equal to end, in that case we have to return -1, because there is no possible such missing element exists. Now our core idea, from int I is equal to 1, I less than n minus 1, so we are going till n minus 2. And if my start is equal to nums of I, okay, if in case, then I'll mark start is equal to -1. If my end is equal to nums of I, my end I will mark it as -1 as well, and we will return the mat dot max of start and end. Why? If that exists in the rest of the array, I don't have to consider, so I'm marking it as -1. Now let's run this. Okay, somewhere we have return. Okay, return. No. Okay, let's run this again. So we use the same logic. There are three main points. Let's submit it. First is the case k is equal to 1, k is equal to n, and the rest is the core idea. So instead of checking everything, what was the brute force? If you are just think you don't get this idea, you would have find the case size subarray every time, maybe using the sliding window or something, and would have find, or something you would have done using the square. But that's it, you can solve this question using this approach. This is a very easy approach and very easy to understand. So thank you so much for watching this video. If you feel this video is helpful to you, please like this video, subscribe my channel, stay updated. Thank you.